Hey everyone, welcome back to Drill Coding. This is part 8 of our top 10 Java interview question series. Let's get started. Let's start with really important Java collection topic, the difference between HashSet and TreeSet. A HashSet is backed by a hash map internally and stores elements in a way that makes searching very fast. But remember that it does not maintain any order of elements. When you insert values, you cannot predict their order. On the other hand, a TreeSet is based on red-black tree structure. It keeps your elements in sorted way. So every time you insert an element, it automatically places it in the right spot according to its natural ordering or a custom comparator you provide. The main difference here is speed versus order. HashSet is faster, usually constant time for add, remove and lookup, and TreeSet is slower because it has to maintain sorting, but you get ordering out of the box. Let's see code example. Here we are importing util package, which imports all utility classes including set, HashSet and TreeSet. Then we define a public class set example. Now we are providing main method here, which is the entry point of our program, and here we are creating a HashSet of a string, and then we are adding some values over here, banana, apple and mango, and then we are simply printing this HashSet. And we are doing same thing in TreeSet also. Here we are creating TreeSet, then we are adding here some content, banana, apple and mango, and then we are simply printing it. So if we run this code in our IDE, I'm using Eclipse here. Let's see what will be the output. Run as Java application. So you can see output here. In HashSet, we are not getting output in sorted form, but in TreeSet, we are getting it in sorted form. Like after A, it will start with B, banana. Let's add one more thing in both. So if we again run this, see the output here in TreeSet is in sorted form, and here HashSet is not maintaining any order. So this is all about HashSet and TreeSet. Let's move on to second question. Second question is, what is autoboxing and unboxing in Java? This is Java's way of making life easier when working with primitive types and wrapper classes. Autoboxing means Java automatically converts a primitive type into its wrapper class. For example, if you assign an int to an integer object, Java does this conversion for you, and there is no manual steps needed. I'll show you in example later. Now talk about unboxing. Unboxing is the reverse, which means Java converts the wrapper class object back into a primitive type automatically when needed. In this example, we have a public class boxing example, and here we have this main method. Then we declare a primitive int variable with the value 5, and here num is automatically converted to an integer. Now we will print the autoboxed value here, and in unboxing we are creating an integer object, and here we are converting this integer value to int, and then we are print the unboxed value here. So let's run this code. Let's see when we run this code what will happen. So this is the output. Autoboxed integer is 5 and unboxed is 10. This feature is super handy because it makes code cleaner, and you don't need to write integer.value of or int value method manually all the time, because Java just does the conversion for you. So autoboxing and unboxing make your code shorter, cleaner and more readable. Moving on to the Executor Framework. This is a game changer for writing multi-threaded code in Java. Before the Executor Framework, we used to create and manage threads manually using the thread class. That meant a lot of boilerplate code, and managing many threads was messy. The Executor Framework simplifies this. You just submit the task, and the framework handles thread creation, scheduling and execution for you. So in this code example, we are importing here concurrency utilities. We have this executor example class here. So inside this main method, we are creating a thread pool of 2 threads. Then we defined 2 tasks using Lambda expression, and after that we are submitting task 1 for execution and then task 2 for execution. Then we use shutdown here, which will shut down the executor after task finish. Let's run this code. This is our output. Task 1 executed by pool 1 thread 1 and task 2 executed by pool 2 thread 2. Did you notice how easy it was? No need to explicitly create and start threads for each task. And the best part is that this framework provides scalability. You can configure thread pools, reuse threads and control concurrency in a clean way. So whenever you have multiple tasks to run, prefer Executor Framework over manual thread management. It's clean, efficient and widely used in real-world Java applications. Now let's talk about streams versus collections. Collection stores data in memory like a list or set. On the other hand, streams don't store data. Instead, they provide a way to process data. Think of collections as a container for elements while streams are a pipeline for processing those elements. In our example, we have this stream example class and we are creating a list of numbers, and here we are iterate over the list using a traditional loop, and here process the list using a stream and print each element concisely. Let's run this. This is the output through traditional loop, and this is from Stream API. This is how streams let us write declarative and concise code. Instead of writing loops, we just told Java what we wanted. And there's another cool thing about streams is lazy evaluation. Operations like filter don't run until a terminal operation like for each is called. So collections are about storage and streams are about data processing. If you need to transform or filter data quickly, you use a stream. If you need to hold data, then go for collections. Next, we have annotations. It's a really important feature for modern Java development. Annotations are like metadata that provide information to a compiler or runtime. They don't directly affect code execution but tell Java or framework how to treat your code. For example, override annotation tells the compiler that a method is overriding a parent method. If there's a mistake, Java warns you. In frameworks like Spring, annotations like AutoWired or REST controller make code configuration easier. Instead of writing XML, you just add annotations. In our example, we declare a custom annotation, my annotation, and in Java, this interface annotation is used to create annotation. Then we declare a single element named value in this annotation. When applied, user must provide a string for this value. Then we declare a regular Java class demo and apply our custom annotation to the show method and passing hello annotation as a value. It shows that you can even create your own annotation for special purpose. So annotations make your Java code more readable and easier to configure, especially in frameworks. Now let's discuss try with resources, which is all about automatic resource management. Before this feature, whenever we used resources like files or database connections, we had to manually close them in a finally block, and forgetting to close them caused memory leaks. With try with resources, you declare resources inside the try parenthesis, and Java automatically closes them when done, even if exception is occur. In our code example, we define a class try with resources example, and also we imported buffer reader to read text efficiently and file reader to read character files, and imports the exception class for handling file errors. And this is our entry point of our program, that is main method. And here this is a try with resources block, and we creates BR which will automatically closed after this block even if exception is occur. It reads and print the first line of the file, and if file errors occur, it will catch the exception and it will print the error stack trace. Then we close the catch block and then main method and then class. So there was no finally block, and Java handled closing the resources for us. And always use it when working with IO or database resources. Let's move on to next question. Now let's look at Lambda expressions. Lambdas make Java code shorter and easier to read, especially when working with functional interfaces. Before Java 8, writing an anonymous class for a simple task was very messy. And with Lambdas, you just write the logic in one line. In our example, we create a list of names and use for each for iterates over each name. Here, this is a Lambda expression. It takes a parameter name and prints it. This is very useful when working with the streams, collection and event listeners. It makes your code more declarative and functional. So lambdas are a modern way to write cleaner and more expressive code in Java. Let's move on to record classes, a relatively new feature in Java. Records are a quick way to create data carrier classes. Before records, we write a class with private fields, constructors, getters, toString method, equals method. That's a lot of boilerplate code. So with record classes, you just declare it and Java generates all that for you automatically. In our example, we declare a record class with two fields, name and age. Java will automatically create constructor getters equals hash code and toString. Then we created a class record example. In our main method, we creates a person record instance with name Alice and age 25. Then uses the auto-generated accessors to print details. So there's no extra code needed and you still get a fully functional class with all the boilerplate implemented. Records are perfect for immutable data objects where you just store and pass data around. Now let's talk about sealed classes. This is about controlling inheritance. Normally any class can extend another if it's not marked as final. Sealed classes let you explicitly say which classes can extend it. In our example, we created a sealed class shape and allowed only circle and rectangle to extend it. This gives more control over your class hierarchy and makes your design safer and more predictable. Sealed classes are useful in domain modeling where you want a fixed set of subclasses. Now let's discuss parallel streams. It's a great way to speed up data processing. A normal stream processes elements one by one on a single thread, and a parallel stream splits data into chunks and processes them on multiple threads concurrently. In our example, we create a list of integers, and here we create a parallel stream where tasks are split across multiple threads. Then we print each number along with the name of the thread and processing it, showing parallel execution. So parallel streams are powerful, but use them only when you are working with large data and operations that can safely run in parallel. For small datasets, the overhead might make them slower. So parallel streams are all about performance optimization when used wisely. It's all about today's video. If you found this video helpful, then don't forget to like, share and subscribe. See you in the next video. Till then, keep learning, keep coding.